Some of you might remember last year me recapping this Technics SU3500. I basically replaced every single capacitor in it. I bought this amplifier probably 3 or 4 years ago. Used to own one of these, lovely amplifier, very fond of it, probably my favourite amplifier, sort of amplifier I would end up keeping if I had to only keep one. And I've been using it on and off in my bedroom as a sort of like a backup amplifier. It's not my main system, but straight from the word go, I did always notice that it had a bit of a sort of 50 hertz hum, particularly noticeable through headphones, not so noticeable through loudspeakers. And I thought, oh, maybe because the couple of the electrolytic capacitors, the main reservoir capacitors I put in it, were capacitors that were kicking around at work that were brand new, but were actually, when I looked, didn't realise the date code was 1984, which was, I was surprised that they looked ultra modern capacitors, unless that isn't the date code. But they checked okay, the ESR was low, they're good quality capacitors, they're not rubbish, they're mil-spec capacitors. So I initially assumed, oh, maybe they're a bit dried up, or they just need a bit of reforming and they're going to get better, but it hasn't got better. It's stayed exactly the same as it was. It's not a problem if you're using loudspeakers really, but it is there, and it's there all the time, and you can hear it all the time when you've got the headphones on. And I'm sort of almost now, rather than listening to the music, listening out for this 50 hertz hum. So what I did today, before I brought it down the workshop, I thought, well, let's try and ascertain if it's a preamplifier or a power amplifier that's getting the 50 hertz. Because I thought maybe what it was when I rewired the power supply up, the big electrolytics, I've moved a ground point and it's induced an earth loop or something like that. But so what I've done is it's unaffected by volume, it's unaffected by input, so that's sort of suggesting initially power amplifier stage. But what I did was I removed the links from the back of the amplifier that coupled the preamplifier to the power amplifier, and the 50 hertz went away, the hum went away. So what I'll do is I'll show you on the scope. I've got it wired up to the scope at the moment. That's the output on the scope. Now, it sounds like a sinusoidal waveform, but actually on the scope you can see, and I've got quite a lot of averaging on the scope to try and filter out some of the higher frequency stuff that's getting through, just the amplifier noise, etc. And you can quite clearly see there with our markers are set at, we've got a 50 hertz breakthrough. So what I want to do is try and investigate what the problem is. Now I'll just show you, if I disconnect the back of the preamplifier connections, I can get around, stick my head in the way quickly to find them. Where are they? Okay, and pull the preamp, just separate the section. There you go. You see it fades away to nothing. Just general, very low level background noise. So that's good. That's basically confirming to us that it isn't the power amplifiers. The power amplifiers are quiet. It's the preamplifier. So what that means is there's a preamplifier regulator on this unit, and it composes of a couple of linear regulators making plus or minus 40 volts. Now all that area is being recapped, but what I want to do is just take the cover off and just ascertain that the capacitors I put in there are the right value. And if they're the right value, I want to see if there's ripple on the output of the regulator. If there's that ripple on the output of the regulator, then we need to investigate maybe adding more capacitance or a better quality capacitor to try and get rid of this ripple. Now from memory, I think the capacitor is a 220 microfarad at sort of like 63 volt. I just need to, we'll pop the cover off, have a look inside and just check those values. Okay, here are the two regulators I mentioned. We've got a plus or minus 40 volt on these two heat sinks here. We've got two adjuster pots on the top there, as you can see, for adjusting the 40 volts. Now you can see these caps have been replaced. Now, I need to check the circuit, but I'm pretty sure the caps that are the output of that regulator are just out of frame here, just behind this bar. But these two capacitors here, which are Panasonic, should be lowest ESR capacitors. So the first thing I'm going to do is going to have a look on the output of that regulator and just see how much noise we've got on there. So let me just connect the scope up and get that all set up. Just starting to have a look inside this and notice that these 2 points here, these two capacitors are missing here. You see these are C504 the 505, and I'm thinking, I can't have left those capacitors out. I was pretty thorough doing the job. Anyway, what I've done is I've taken the back off, and they're actually in parallel with these other capacitors. And obviously, as capacitor technology has improved, the capacitors are less than half the size. So I've managed to put in the same value capacitor well, double the value capacitor at the same size. So I'm just going to look at the output ripple on these rails now. And these two outputs come from two convenient test points at the top, test point 2 and test point 3. This is test point 3. Just set the scope up so you can see what's going on up there. It's a bit fiddly trying to get everything in as always. It's always a bit difficult to juggle about, but here's the scope. So we're on 5 millivolts per division, and you can see there's next to no ripple at all there. So it's very clean. That's not a problem. Let's check the other test point. And that's pretty good as well, so there's no sort of sign of any ripple there. So what I'm going to do now is start to measure across some of these capacitors just to see if any of them got high ripple on them. So I'm going to start with these two capacitors down here. I can't see what I'm looking at. Let's pause. So we'll have a look at these two capacitors here just to see what they look like. And the scope's all floating, so hopefully it's not going to cause any problem. It's a plus and minus rail this, so of course now you can't see the scope. Very awkward. Okay, it's got a lot of ripple on that. Let's turn that down to 200 millivolts. Okay, we've got a big ripple there, and on the other side, same sort of thing. So, what I'm going to try, I think what I'll try is I'll put some extra capacitance across those two capacitors just to see if that actually quietens the thing down. So let's try that first. Okay, we added some more capacitance across those capacitors. That's the input of the regulator, and you can see it's made very little difference at all. So I don't think that's the problem. And when you monitor the output, this is the ripple across the actual capacitor. When you actually measure across the speaker, it's more or less the same. So I don't think the noise is getting in here. So the next thing to do is actually probably have a look around the power supply and see where else there could be a problem. It could actually be an earth loop or something like that where I've connected a ground up the wrong place. But so let's disconnect these two capacitors I've put on, and we'll see if that. I'll start looking somewhere else for something else that's wrong. I'm going to hope you can see this. Right, so these are the two capacitors that normally are in parallel. This is the output of the unregulated supply straight from the power supply. You've got the rectifier here, and then we've got the large 10,000 mic caps that are now actually 18,000. They're the main power supply reservoir filtering caps. And then it's fed off to this secondary stage here, which is another filtering circuit. And these are the two capacitors that were supposed to be in parallel, usually 220 at 63, and I've replaced over with 470, just one capacitor, so one of these caps has been omitted either side. This is where we try to increase the capacitance of the rail to see if we could reduce the ripple there, but that made no difference to the output ripple, the audio ripple on the output stage, or output of the preamplifier. Unfortunately, I can't monitor the preamplifiers directly output because the level of the ripple's so low there that the scope's not sensitive enough to see it. But sure enough, if you disconnect the preamplifier, the ripple goes. You can hear that, the ripple goes. So it's not coming in through the power amplifier. So this is the regulator circuit here, and then you see this capacitor here. These are the 220 microfarads. and they are 330 microfarads. Sorry, there's a final output ripple suppression. So I think the next thing to do is I'm just going to put some more capacitance across here. It could be that the capacitors I've got aren't particularly low ESR, and it may be that this is just on the beam end of not quite enough capacitance to filter it out. Though even though the ripple looks pretty good at this point, there's clearly audio getting through, and I'm starting to wonder now. I need to check this circuit to make sure. I'll have a look in a minute to see if this is actually just not a preamplifier, so a phono amplifier's regulated supply, in which case I'm barking up the wrong tree and I need to come back to the main reservoir capacitors, the large 2 electrolytics. So I'm just going to have a quick look at the circuit, and then if that's if I'm confirming that this preamplifier is actually supplying this regulated supply is actually supplying the preamplifier, not just the phono stage, we'll investigate a bit further. Just to make a couple of points here. These capacitor here, my finger is just here, and also the associated capacitor with the other side of the amplifier were the wrong values. Now I don't know if that's because I put the wrong value in or the original one was the wrong value. There's two there. They're supposed to be 47, they were 22, so I've replaced those with 47, but that's made no difference at all to the main, sort of like the 50 Hz hum I'm getting, and it's only particularly noticeable actually through the headphones for some reason. Now, what I have tried a couple of things is, this is input to the tone controls here, this point here, 204 is this? Yeah, this point here is an input to the amplifier, so I've grounded that to its associated ground point, which is down here, and the hum's still there, so it's suggesting it's not coming in from that point here, it's at a later stage in the amplifier. I've got a funny feeling it's probably in the sort of final stages of the preamp around here somewhere, maybe where I was working with that capacitor earlier on, these capacitors earlier on. So we're looking at the moment to try and work out where the sound's getting in. Now, it could be an earth loop problem. It could also be a filtering problem, and I'm starting to wonder now if it's actually sort of always had this mains hum in it, because these headphones are very sensitive. I can pick it up. You can't actually hear it on the speakers, even if you put your ear really close to the speakers, and maybe just about. So the other thing I could probably do is run it on the audio analyzer and do a signal to noise ratio check on it and see if it's actually in spec. But it's noticeably more hum than the amplifiers I've got, so that sort of worries me a little bit that it's not right. So basically we grounded this point here where this decoupling capacitor is here, this capacitor here that goes into base to these transistor here. So if I ground that point to 0 volts, you still got the hum. And there's another stage here that I could probably ground, which is on the output of the amplifier. Might be the next point to look. I just need to ascertain there isn't any DC offset on these points, because if there is, you're going to damage something. So I'll stick a meter across there down to chassis, see if we've got the hum there. If we've got the hum there, ground it, and if the hum goes away, we narrowed it down to this part of the circuit here somewhere. This part of the circuit here. So let's give that a go. So I'm going to try and find that test point here, or this point here, and so we can put a link across. Now this point here, pin 3, is the output of the tone control amplifier. If I ground that to its associated 0 volt point, which is pin 2 here, the hum goes away. So that's interesting, because if I also make an extra connection from pin 2 to a local ground, the hum gets worse. So I think our problem here is actually an earthing problem, a circulating currents in the amplifier somewhere. So I think the thing to do is, we're not looking for supply filtering, I don't think. I think what we're looking for is an earth loopy sort of problem. So what it might be worth trying to do is putting in some better ground points to the tone control amplifiers. And see if we can improve on that. Now these points are here. Let's turn this amplifier off so I don't... Okay, so there's a couple of signals. So that's the ground points, that second pin there, and the third pin is the output of the tone control. So if I ground those two together, it quietens the amplifier down. This point here is the earth, so I'm going to try and improve the earth bonding. Now it goes back to, it's got this capacitor here that's hanging off this here. I'm not sure why that's there. I'm going to try and work out what that is, but This itself could be causing problems. I might disconnect the end of this capacitor and just see what that does. But I assume it would be the same on the other channel. Here's the other side here. Here, 1, 2, 3. It's the same one, I think. That's the same end. Check that. But it could be something to do with this earth connection, this connection from this capacitor. So let's have an experiment around here, and I'll see what we come up with. I've been through a number of things trying to work out why this amplifier is humming, and it's actually pretty conclusive. It's actually an earth loop problem. You can see, show you here, the grounding of the amplifier is on these pins here, and you can see that that's the thicker line is the ground lead, and the same on the other amplifier. Now, if I put an extra ground point, and this is on the bottom of the amplifier, to various different places, you can actually make it slightly worse. And sometimes, depending where you mount it, the other end of the wire, you can actually improve the hum slightly, but it never makes it totally better. So I've been tracking through, and this ground lead also runs to the other end of the top of the tone amplifiers, which are just here. And these are the ground points here on the top of these amplifiers. You can see that the center connection on the top of the amplifier. That's the ground audio for the ground. And from there, it follows on down to the potentiometer, and the potentiometer's here, and you can see one of the potentiometers grounded. So that's the potentiometer here, and I've added an extra wire. It's just taken quite some time digging around trying to find what it is. And this is my wire coming out here with this crimp tag on it, and I find, so I've got headphones on at the moment, and you can't hear it, and the level is so low, but you have to trust me on this. If you ground it here, the hum goes totally away, and the amplifier still works. So it's circulating currents in the tone controls, and that wiring is the problem. And this is one of the more tricky faults to find, and sometimes you can never fix these problems. I would like to think I've had some skill in fixing it, but it's a bit of luck as well. So, I mean, the hum here, funny enough, is better than if I ground it on the front panel. It's not as good there. Now, that's probably down to earth bonding. The screws may not be tight on the front panel, or as tight as they should be, but certainly altering different positions on the chassis improve the earth, the hum. And yeah, here I can barely hear it. It's perfectly acceptable now, and it's back when I take it off. And I'll try and demonstrate that on the scope in a second. So it looks like, yeah, circulating currents in the amplifier for some reason. So what I'm going to do now is going to try and wire it up into the scope so you can see the difference, and then I'll find a final point. There's a tab there I see at the back there. I might be able to screw it to that. That might be a good point. But we'll have a go and see what we find. Okay, this is the best representation I can give you of this 50 Hertz breakthrough. We're at 5 milliseconds per division. You can see the sort of like a crude square wave. That's our 50 Hertz breakthrough from the through the amplifier. I've got a lot of averaging on at the moment to try and filter out some of the high frequency noise, because obviously the amplifier generates high frequency noise as well, but we're interested in getting rid of this hum. So this is with the screw connected, the wire connected. So what I'm going to do is I'm going to ground that connection, and we'll watch what it does. It's grounded. See it coming right back down, almost fading away to nothing. Much better. Can't hear it at all. Remove it, it comes back again. So it's impossible for me to let you hear this because it's at 50 Hertz, which is probably 100 Hertz fundamental or harmonic. There's no way you're going to hear it through this microphone of this video camera recorder thing. But simple enough fix once you find it. Just find a decent ground point, and I'm just going to go through and try and find the point where it produces the least hum. It's interesting how critical this is. Let me just show you this is the screw connection I said I might try and ground it to. So we'll try it on that screw hit point here. Sorry, this is all handheld. So this is our normal waveform. Let's just reduce the volts per division slightly so you can see what's going on. Okay, that's our 50 Hertz breakthrough. and that's normal, that's how it was. And if I ground it to that point, it actually inverts the phase and makes it worse. You see that? So what it's doing is it's the current's obviously circulating in a different direction, and now we've got a much more hum, but in a reverse phase. And I take it off, you watch that the phase drops away, and then it inverts again. I mean, it's the reason why it's doing this so slowly is because as I say, I got a lot of averaging on. Let's go to normal actually. Okay, so ignore the high frequency junk on the scope. Invert it. There you go, and it's worse. That's where the averaging is quite useful, because it actually does show you what's going on. So what I'm going to do, as I say, I'm just going to move this wire around, find it the best place where I can screw it to the chassis and get our best hum performance. So I'm going to go back to averaging, and I'll sort that out, and then once I've finished that, I'll show you the result. Right, I made a connection to the chassis of the amplifier, and that goes up to the volume control, and that sort of makes sure that the grounding is better on the. Okay, I made a connection here to the chassis of the amplifier, and that connects to one of the ends of the wiper, or one of the ends of the tracks of the volume control, and that's reduced the hum by, well, a big amount. You can hardly hear it through the headphones. But what I've done is I've removed the front panel just to make sure that all these screws are tight, because obviously it relies on these screws to bond all the earth together. And I'm not sure that that's actually the problem or not, but screws like here and anything that's sort of mounted to circuit boards and things like that need to be checked to make sure they're tight. Actually, they're irrelevant. They're just all the front face here on here. Get the camera to focus. But also all these screws for speakers and tone control switches and things like that, and likewise all these pots, because obviously this pot is where it's supposed to be grounded, and it's not doing a very good job. So it's worth checking all this. If you've got an amplifier with a sort of like a slight hum in it, just make sure that all these screws and fastenings are tightened up. So that's what I'm going to do now. I'm going to whip round, check all those, and then we'll pop it back together and we'll have a look and see what the results look like on the scope. Okay, so the final result. Amplifier's all back together again. I've got this connection here. I've disconnected at the moment, so you can see the difference. There's the waveform there. So we're only looking at a tiny output. That's on the speaker output of about 6 millivolts peak to peak, with a lot of averaging, but it's, you wouldn't hear that really on the speakers unless you had your ear right up against the woofer. But let me just ground it, and you see it drops back to about 4, and it actually looks less on the scope, and I think it also depends because the scope's actually floating, or it's actually on an isolation transformer, so it's probably not an ideal representation of what the true ripple is, because I think if we've got a phase difference on the transformer, if the input of the transformer is slightly out of phase, it might cause a sort of like another problem with earth leakage and earth loops and things like that. But certainly through the headphones it's a lot quieter, and tightening those screws up seems to have improved it slightly as well. So yeah, that's it really. The amplifier is going to be put back together, and I'm going to stop twitching about it and start using it because it's such a lovely sounding amplifier. So let's get it back together, and maybe we can actually enjoy it. When I plug the headphones in, I don't hear that 50 Hz hum and sort of worry about it and have to take it all apart again and refix it.